Let's start with the second part of quality engineering. So both QA and QE are deeply concerned with the user experience and actively work to improve customer satisfaction with each new release. This common ground is why metrics like test coverage are relevant for both disciplines, provided the quality team has a strategy in place for ensuring test coverage reflects the customer experience. QA measuring the end result. Since QA is primarily concerned with measuring quality agent against a set of specified requirements, QA's metrics are more closely tied to overall product quality and how users perceive quality. To assess the success of QA strategy, testing teams might consider how long it takes to run a test plan, how often QA is holding back releases, and customers centric metrics like churn rates or satisfaction rates. QE measuring the process. In contrast, quality engineering has a wider focus that seeks to understand quality as code moves through the SDLC. By shifting testing to the left, QE is able to quantify issues earlier in development for a more nuanced way. To that end, QE metrics are embedded into development pipelines and aligned with this entire SDLC. Automated tests of all types, functional, integration, E2E, performance, load, API, etc., are created to find defects earlier in the pipeline so issues can be fixed at much lower cost compared to escaped bugs that are first reported by customers. This way, the entire defect discovery and resolution process, issue identification, the delivery of bugs, bug fixes, and ensuring new features don't break existing features is accelerated. Developers and quality engineers alike then have more time to dedicate to building new features and improving overall quality. Quality engineering is a journey, not a destination. The difference between QA and quality engineering is steps, not miles. As QA teams expand their automated strategy, testing strategy, enhance their manual testing and shift testing to the left, they are able to measure new aspects of quality. When the quality is better quantified across the SDLC, quality teams are empowered to embrace quality engineering and enable DevOps adoption. What is software quality engineering? Software quality engineering is the practice of integrating quality checks throughout the development cycle of software tools and applications. Its purpose is to ensure that software development team is efficiently testing for quality throughout the product development cycle. To do this, software quality engineers must closely study existing development process so that it can integrate the quality checks rather than add them to the top. Software quality engineers are responsible for the design, development, and maintenance of the practices or policies and procedures used for improving the efficiency of quality assurance. Software quality engineering practices. Software quality engineers are several practices to ensure a high quality product. Some of these policies include peer review. Peer review is when the software developers share their code with one another. Having programmers review each other's code provides two major benefits. First, it makes it more likely that they will spot any error by giving each piece of code additional reviewing. Second, it allows the programmers to learn from one another. Programmers can share advice or suggestions to help improve the software's code, which ultimately leads to a better product. Code analysis. Software quality engineers integrate analysis tools directly into programmers' coding environment. Through these tools, the programmer gains real time feedback about their work. ensuring that it conforms to predefined quality standards. This real time code analysis saves the development team time by eliminating problems before they become ingrained within the program. Testing. There are several testing practices that software quality engineers use. One example is functional testing, which tests the user interface of an application to ensure it conforms to the predefined protocols. Along with testing out of the core functions of the program, functional testing also analyzes the performance of features such as menus and installation process. Why is software quality engineering important? Software development teams use software quality engineers because they can provide the following benefits. Better final product. By checking for quality throughout the development process, software quality engineering ensures a better final product. It handles more problems and inefficiencies during the development process so that there are fewer when it comes time to deliver the product to the customer. Software quality engineering also promotes collaboration among developers who can then share ideas for improvement. This encourages an environment where the developers can find the best ideas and implement them. Faster delivery speed. Through practices such as automation and the use of artificial intelligence, software quality engineering significantly reduces the amount of time spent on testing. Because of this, developers can finish the software faster and deliver it to the customer sooner. In software development, delivering the high quality product to the customer in a timely fashion is one of the most important attributes of any development company. Therefore, faster the company can deliver a product without sacrificing quality, the better. More adaptable. When developing software, you may face unexpected challenges. For example, a client may request major changes in the product in the middle of the development. Software quality engineers help their businesses implement what is known as agile development practices. These allow development teams to quickly and efficiently make changes during the process, ultimately saving time and resources. Software engineering lifecycle. It takes far more than coding to create software that meets the user's needs and continues to do so over time. Software is created and maintained through a structured process called the software development lifecycle. There are many variations. The waterfall lifecycle is sometimes called the classic model. Other models borrow from it and improve upon it. The waterfall method can be seen as a response to unplanned code and fix software development, and many other models can be seen as the responses to waterfall. The waterfall lifecycle model. The classical waterfall model has discrete stages, each one flowing into next. There are 6 stages: requirement analysis, design, implementation, validation, installation, and maintenance. In the initial stage, software developers determine the functional and non functional requirements. This is sometimes called a requirement extraction because software engineers may have to dig to uncover the true requirements. At the onset, the clients may have only a vague idea of what they want the software to do, and they may not understand the needs of the end user. There may be contradiction. The requirement process typically includes putting together a set of use cases. The evolution of and life cycle of quality engineering in software. Software quality engineering has been undergoing a renaissance with organizations pulling out of at all shops to prevent or catch defects as early as possible. This has led to slew of a new tools and methods, including test automation, shift test, shift left testing, DevOps, DevSecOps, continuous integration and continuous deployment, that is CI/CD, SDET, test driven development, TDD, and behavior driven development, that is BDD, risk management, and artificial intelligence. Software design includes both architecture, putting together the big picture, and writing algorithms. The complexity of the design process depends on a number of factors, including whether there is an interface for the or the entire program is automated. Implementation refers to coding. At this stage, developers have a well-known, well-formulated plan. It has to be put into language into the computer that can understand. Next stage is deployment. This involves not only releasing the software for use but retaining users and offering technical support. Iterative and incremental lifecycle methods models. In spiral and iterative lifecycle model, development passes through the same stages but does so multiple times. As the product is refined, each turn or iteration wraps up and planning for the next one. Some iterations don't actually involve product releases, but they will typically pass through at least the first four phases of the life cycle. The development process may stretch across quite a few years through the product, though the product may become available for use early on. The most basic functions may in fact be available sooner than they would if the classic waterfall model were utilized. Now, functionality is added with subsequent releases. There are a number of variations on the iterative model. The word spiral is typically used for projects that have long iterations. Spiral models are often used for high budget software. Risk analysis is a key component and is built into each turn around the spiral. Incremental models also involve traveling through the development stages more than once. A key difference is that the project is broken into chunks at the onset, and each section is carried through the developmental process before being integrated into the whole project. Projects out in the real world may involve both an incremental process and an iterative one. Agile models have very short iterations, sometimes as short as a week. They can be effective from a business standpoint because clients have frequent opportunities to see an actual product as opposed to a stack of paperwork. Some agile methodologies are used by only for particular parts of the process, while others provide a framework that can be used from start to finish. Seattle University, which has earned while a reputation in the software engineering field, uses an agile model for senior and graduate projects. The model works well in many software engineering contexts. The chair explains. It is particularly useful for teaching as short iterations mean lots of opportunities for feedback. Still, no one model is effective for all situations. That's one reason students learn to function effectively within multiple frameworks. Agile models have very short iterations, sometimes as short as a week. They can be effective from a business standpoint because clients have frequent opportunities to see an actual product as opposed to a stack of paperwork. Some agile methodologies are used only for particular parts of the process, while others provide framework that can be used from the start to finish. Seattle University, which has earned quite a reputation in the software engineering field, uses an agile model for senior and graduate projects. The model works well in many software engineering contexts. The chair explains it's particularly useful for teaching as short iterations mean lots of opportunities for feedback. Still, no one model is effective. All these combine from an emerging approach to quality engineering. Quality engineering's life cycle, that is what one can see on the screen with this block diagram. Thank you.